AI financial agents function by translating chaotic probability into deterministic output. This is the DeltaSignal Gemini AI agent. It produces bounded evidence objects rather than unconstrained opinions. We will deconstruct an A2A response generated from a public Hut8 Substack article. In this generated payload, the highlighted boundary fields ensure execution fidelity. Reliable agentic memory is defined by the structural constraints of its output. This diagram maps the deployed Go Cloud Run and Lit architecture. The interface exposes live, protected API routes. Unstructured public data starts the research loop. A trip code serves as the mechanism to anchor the text. It locks on to sequence TF sub 9 DA70AF98. This sequence acts as a stable resolver handle. It transforms static text into executable context. The deterministic workflow requires this resolved state. The Cloud Run agent relies on this state to interpret user intent. Cryptographic locking makes unstructured web data usable for agents. Data packets flow systematically from the backend into the Gemini model. Passing financial data into an LLM often risks unconstrained extrapolation. Atlas 7 provides the critical constraint. It enforces an impermeable evidence boundary around the model. The perimeter strips unstructured text of unverifiable data points. This is the core of evidence-bounded execution. It replaces standard chatbot methodologies with structural limits. The architecture prevents the generation of unconstrained investment advice. Gemini and the Cloud Run backend orchestrate the workflow in tandem. Successful execution yields a usable research packet. This bounding process separates a deterministic agent from a probabilistic generator. Atlas 7 converts model outputs into verifiable financial evidence. Within the resulting data object, live request traces prove bounded execution. Article memory and river context arrays verify the source material. Usage accounting and disclosure fields enable enterprise auditability. The DeltaSignal interface employs a dual-view system. Raw JSON acts as a machine-readable audit trail. The interface simultaneously renders this packet for human evaluation. The packet includes an A2A discovery mechanism. The A2A agent card exposes specific interface skills to external clients. These skills include resolving trip code packets and monitoring marketplace scenarios. Research becomes portable, discoverable agent memory rather than an isolated report. The system's utility continues after the initial data extraction. On this timeline, the original trip code evolves into a stable thesis baseline. The agent monitors new signals against this baseline. Incoming data is automatically routed and checked against research parameters. It surfaces confirmed signals. It flags weakened assumptions, stale evidence. Invalidation checks execute autonomously. Monitor next actions are restricted by the non-advice boundary. This continuous validation process represents live financial memory. Architectural value is found in maintaining research validity over time. Looking at the macro view, we see the entire DeltaSignal pipeline. It converts public research articles into agent-executable financial memory. Trip codes resolve context, Atlas 7 enforces boundaries, and Cloud Run delivers A2A artifacts. The final output is a packaged, bounded evidence object. The protocol requires the agent to rely on the source material instead of model extrapolation. This powerful architecture enables AI agents to discover, verify, and reuse financial memory through a continuous, verifiable data loop.